Hello everyone, and thank you for joining us for another session on how to network with C#. Apologies for not posting any new content. Due to health reasons, I was unable to do so. Here's what we're going to learn this session. We're going to learn how to network with C# using TCP and connect also using FTP and HTTP. So let's get started. Before we get started, let's understand how networking works. This is by no means a comprehensive review, but a quick introduction. We use the network card of our system to communicate with other systems over the network. For example, a Windows PC can communicate with a Mac or a Linux system. From a networking standpoint, our system doesn't care what the endpoint is connecting. This is achieved by using a standard called OSI. OSI stands for Open System Interconnection Model and is a framework that describes the network system. OSI is broken into 7 layers. For example, a web browser will interact with the application layer. A few things that the application layer is responsible is identifying communication partners, resource availability, and synchronizes communication. The next level, the presentation layer, is responsible for representing and translating data between application and network formats. For example, this layer can also handle the encryption and decryption required by the application layer. The session layer manages the connection, reconnection, terminating communication between computers. The transport layer manages the delivery and error checking of data packets. The network layer is responsible for transferring packets from one system to another, and the data link layer directly connects systems and the data is transferred into packets. And the physical layer is exactly that, where the raw data, the packets, are transferred into digital bits of electrical radio or optical signals. Now that we have an introduction of what happens in our network card, let's talk about the most common protocol, TCP, that is used to communicate between systems. TCP, Transmission Control Protocol, is a connection-oriented protocol that facilitates the exchange of messages between systems in a network. TCP is mapped to the transport layer of the OSI model, and IP is the Internet Protocol where it sends packets across the network. So how does this fit all together? Let's say our browser makes a connection to a web server. The server will send an HTML file back to the browser. The server requests TCP layer to send the file. TCP will divide the HTML file into packets and sends them over to IP for delivery. So in this example, we're going to emulate a TCP server listening for connections and then having a client connect to it. So we're going to create 2 programs here. We have a very simple console application, and we're going to go ahead and start using the namespaces system.net and the system.net.sockets. And that should give us access to all of the classes that we need. So in this class, in the main method, what we're going to do is we're going to go ahead and put all our variables and code to where it's going to launch a TCP server, but we're going to use a TCP Listener class to listen for connections that are coming in, and then do a very simple echo based on the response, the request that we get, and then the response is going to be just echoing back the message, but having it uppercase. So the first thing is we need to have a port. We're going to go ahead and use the port 13,000, and we want to make sure that this port is not in use, otherwise you'll get an exception. So whatever port you're using, make sure that it is not being used by your system. So the next thing we need to do is figure out the IP address. Now we're going to be emulating this on the same server. So instead of using our IP address, we're going to just use a loopback, emulate the server and client connection. So once we have our IP address set, we'll go ahead and create a TCP listener. But we're going to create this TCP listener and set it to null because we're going to do a try catch finally. And we're going to create the TCP listener inside of our try catch. So on the catch exception, we're going to go ahead and set it so that it is a catch all. So we're just going to have a catch exception. And then when we do receive an exception, we'll just go ahead and output the exception message. So now we're going to go ahead and initialize the server by creating the TCP listener and then passing our IP address and then the port. So those are the two pieces of information we need in order to get our TCP listener started. So then we're going to go ahead and start our TCP listener. Now, one thing to note is that in this example, we're making this so it's serialized, meaning that if a connection comes in, we're going to go ahead and put in the queue. And this happens because we did the server.start. So if we just say server.start and make connections, they all go into a queue. And then you'll see later on when we actually take a connection from the queue and then be able to process it, and that'll be a blocking call. So if you wanted to have this to be multi-threaded to really handle it or have some kind of asynchronous programming in it or both, that's a pretty advanced topic and we're not going to go over this. This is just to show how to connect to a TCP server using a TCP client. So that's why we're creating this TCP listener server. So the next piece of information that we need is we need to take the messages, which will be coming in as bytes through the wire, and they're going to be in ASCII strings. And we just need to have the read the stream into the bytes and then take the byte and convert it into a string and then uppercase that and then send it back. So in order for the server to work is we need to have this a forever loop on the while. And that is so that we can, once we launch the application, it stays live. If we didn't do that, then the application would just listen, and then it would go to finally, and it would stop, and it would not process anything. So this is why we have our forever loop here. And we'll just go ahead and put an output a string for waiting for a connection. And next, we're going to create a TCP client. And what we're going to do is now we're going to go ahead and accept TCP client. And what this will do is that as the loop is going, every time we say server.accept TCP client, if there is a message in the queue on the server, when we did the server.start, then we will take that message, pop it into the TCP client. So once we got the message, we'll output a string that says we are connected. So now from our client, we'll go ahead and get the stream. And once again, we're getting the stream, and we'll probably close it, but the way to do this properly is to use a using around the stream, so that way when the stream is finished, it will automatically close and dispose it for us. So the next thing we need to do is we need to create a variable, a counter, and because if the stream is bigger than the amount of bytes that we have, which is 256, we need to continuously loop until we get all of the stream into bytes and convert it to a string. So in the while statement, we're going to loop to make sure that we've read everything from the stream. So in here, we basically saying stream.read, put the data into the bytes variable, starting from position 0 to bytes.length. And now if that, and then whatever is remaining will go to I, and then we check it to make sure I is not equal to 0. Now if I is not equal to 0, then we've accepted all of the messages. And now we're going to go ahead and use the encoding ASCII. But to do that, we'll go ahead and put another using statement to have our system.text. So now we're going to go ahead. You could have done this through UTF or some other encoding, but we're going to go ahead and make sure that we're using ASCII. So now we're going to say get the string. And the string is going to be basically the bytes that we're working with from the 0 position to the length of I. So whenever we're reading I, that's going to be the length of the stream. And then we're going to go ahead and make this into a string. So now that the data is into a string, we need to now echo this string back. So we need to create another, so we need to take our data and uppercase it and then convert it back to bytes. And this is what we're doing in this line. So we're using the encoding ASCII get bytes, passing our string, but here we're going to say dot to uppercase. So now our message is processed in uppercase, and this we're going to send this back to the caller. So we'll use the same stream object, and now we're going to, instead of reading from it, we're going to write the byte, and we're telling it the start from position 0 to the message length. If this was more than the 256, we would do another loop to make sure that we have all of the values in the stream. So now that we have our data written to the stream, we'll go ahead and put a message that the message was sent. So once the while loop is finished and we've read all of the messages, we need to close our client. So once the server is processed, we'll continue looping to listen for other connections. But we'll put some code in here in case you wanted to put some kind of a command where you would listen for if the user hit Q or escape or something other or enter, then you would get out of the loop, and then we would show this message that the program has exited. So let's go ahead and now quickly build the application to make sure that it actually succeeds. So our build succeeded, we have no errors, and everything looks good. And now if we go ahead and run this application, we should just see waiting for a connection. So now we're waiting for a connection. Since we haven't set up any clients to connect to this IP address and port, it's just going to sit there and do nothing. So let's go ahead and now create the client to be able to connect to this service. So this is going to be our TCP client example, and we're going to have the same information. We need to put the using statement for our system.net and system.net.sockets. Since this is the client connecting to the server, we'll use the TCP client, but we're going to need 3 pieces of information. First, the message that we want to send, and we'll just make it a very simple hello world. Next, we need the port, which is going to be the 13,000. And then after that, we will go ahead and initialize with the IP address and the port that we're going to send. So this will initialize our TCP client. Next, what we need to do is go ahead and use the TCP client to make a connection and then send the data of the hello world message. To do that, we need to convert our string into a number of bytes. So we'll go ahead and use the system.text and then use our encoding class. And since the server is accepting ASCII, we'll go ahead and send it ASCII. So just as before, we'll go ahead and get the stream from the client. And now that we have a stream, we'll go ahead and write to the stream and passing our bytes data, starting from 0 to the length of the data. So now we just need an indication that we have sent the message, and we'll go ahead and console that right there. And then we're going to use the same data variable and make the length 256, and this is going to now receive the data from the server. So we need to have a variable of the response data, which will be a string. So now we're going to go ahead and take our stream and we're going to read by passing it the data starting from 0 to the length. Now if the string was going to be more than 256 bytes, then we would have to create a loop to be able to receive all of it. And now that we receive the bytes, we'll go ahead and use the encoding class and using ASCII to convert our bytes back to the string. And let's go ahead and write a console message that the response was received, so we can output what the server sent us, and there should be hello world or uppercase. And again, we're going to go ahead and close the stream, but to do this properly, you would put a using statement around the stream so that it could be closed and disposed. And now that we're finished, we're going to go ahead and also close our TCP client. Let's go ahead and put this into a try catch just in case if there's any issues. Let's go ahead and use the exception class so we can catch all exceptions. And let's output the message if there's an exception. So we're not going to really need the finally, although we could have put the stream close and TCP client in there. But if we did that, then we would have to create the variables outside of the try. So let's go ahead and now put a message that the program has exited. Let's go ahead and build our application. Make sure everything is okay. And our build succeeded. There's no errors. All right, so now let's go ahead and test this application. We're going to launch the server first so that the server is listening before we launch the client. So our server is now waiting for a connection. Let's go ahead and execute our client, and now we should see a message coming in. Okay, so if you take a look closely, we said that we were waiting for connection, and then our client sent a hello world. And then on the server, we got connected because we received the message, and we converted the hello world to uppercase. So notice that the client does not have the hello world uppercase. So let's take a look and see what we did wrong. So we had an issue where the data.length was not set, and we fixed that, and then response data should have actually been on the receive. So we'll go ahead and we just updated that as well. So now if we execute our program, everything should work and we should see the uppercase. Let's go ahead and run our server. So our server is waiting for our connection, and let's go ahead and run our client. So our client sent the hello world and we received the hello world in uppercase. So next, let's take a look at how to send data using FTP. Now let's take a look at how to work with Ftp File Transfer protocol. To use the FTP, we need the following namespaces: system.io to create and read files, and system.net to work with the FTP. As you can see, we have FTP set up as a local FTP server on our Windows. Also note that if you are using a Linux server, the results of how you get some of the data is going to be a little bit different, and we will point those differences out as we go along. To work with FTP, we need to use the web request class. To initialize this class, we need to call the create method and passing our FTP address. Now, just like you're browsing the web using HTTP or HTTPS, we must use FTP and to indicate we are using the FTP protocol. Next, we need to cast the web request into a FTP web request. We do this because the FTP web request inherits from web request, and the create method exists in the web request. You could use the FTP web request.create. That's another option, and we'll leave that to you, but we're going to use the web request.create and then cast it into FTP web request. So the next thing we need to do is set up the method or the command we're using. And in this case, it's going to be getting a listing of the FTP root directory. Those will be the folders and files within our FTP directory. Our FTP is set up to be anonymous, so we can pass it anonymous as the username and pretty much anything for the password. Although here we've misspelled anonymous and it will not work, and we will see that later on. Once we're connected, we can then get a response from the Ftp server. Next, from the response, we get the stream, and then we're going to read the stream into a string and then display the results, which will have the directory structure. Let's also set two additional properties: keep alive and use passive. Keep alive will keep the connection open, and use passive is both the client and server. If both the client and the server supports it, it will help alleviate some of the issues with the client-side firewalls. Now, if we run our program, we'll get an exception, and this is to having an invalid username. The username must be anonymous, spelled correctly for the connection. Now we get back the expected results, now that we fixed up the username as anonymous correctly. Also note that we mentioned that there would be differences in Linux versus Windows system. The result of the Windows-based FTP structure is different from the Linux system. So if we were parsing it to get the files versus folders, then we will always start with a datetime as an indicator. Great. Now let's move our logic into a method and work with the next section where we will download a file from Ftp Server. For downloading a file from an FTP site, we just need to pass the file name to the URL of our FTP when we make a connection. The next steps will be the same for our credential and keep alive and use passive. Generally, you get a listing of the files and directories when using the file name. If you are fat fingering it like we are, make sure that the file name is exact because it's case sensitive. So we set up the command incorrectly here as it needs to be downloading the file and not getting a directory listing, but we'll fix that in a little bit. To download a file, we need to get the response, then read the response's stream as it will have the file in the stream. Next, we need to get the file name using the pat get file name, and then use it to create a file. And in this case, we're going to create the file in the same directory where the executable is for our program. Then create a 1024 buffer where we will put the content of stream into the buffer and then push that into the file. Next, we need an indicator for the number of bytes read. So now we create a loop and keep reading the stream into our buffer until it reaches 0. And when it does, we break out of the loop. Else, we write the stream into our file. And then last, we need to flush and close our stream. Since we're doing a directory listing, as we mentioned before, we're only getting the list of the file. So let's change that to get a download of the file. And if we execute the program, now everything works as expected. So now let's go ahead and move this code into a method and then work on uploading to an FTP directory next. To upload a file, let's create a dummy file and make sure that it moves to the bin directory when we execute the program. As before, let's copy the web request creation and setting the request properties. This time we'll make sure to update the correct command or method so that we are uploading a file. To upload the file to our FTP site, we just need to do the opposite of downloading. So we get a stream from our FTP request where we will push our file into. Next, we get our file into a stream, then send it in chunks to our FTP stream. Now we flush and close our stream and make sure that we use open as the file stream instead of create as we are reading it. Now if we look at our FTP root directory, we can see our file got uploaded. So that's it for the FTP section. Let's take a look into how we can work with HTTP using C# code. To work with and get data over HTTP, we need to create a sample site. For this, we have already created a web API project. All we did was to create a new project, then select Web API. This will create a default Web API with a sample weather controller for us. If we execute the project, as you can see, we get 5 randomized weather records. We updated this Web API and added a to-do controller that will use an internal database using Entity Framework. We did this so that we can show you how to use to get and post to a URL, as well as delete and put. Okay, now that we have our sample up and running, let's code and work with HTTP. Here we created a simple console application that we'll use to call our web API. We'll work with the HTTP client class and the system.net HTTP namespace. We will make it static so that we can reuse it. When using the HTTP client and making multiple calls, make sure that you have only one instance. So now that we have a reusable HTTP client, we can use the getAsync method to make the HTTP GET request. For this example, we will not use the async and await features. So let's use the weather controller as a sample, and because it has some data to test the HTTP GET. Now the getAsync will return HTTP response. So before we get the content, let's add our code into a try-catch block so that if the calling site results in an exception, we can handle it gracefully. Now we can get the result. To do that, we will get the content, then call the read as string async method, and then output that into the console. Let's go ahead and execute our program. And as you can see, everything works as expected. Now let's call our web API using the get method the same way as we did with the weather control. But this time we should see no records, and the reason for this is that our in-memory database has no records because we haven't added anything to it. Now for the web API, as you can see, the URL is a little bit different, and that is because we're using the routes attribute. The routes attribute forces us to call the getAPI method using the API prefix and then the controller name. And then since we're using a get, it would use the get HTTP get attribute. And let's go ahead and execute our program, and we should see an empty array coming back, and that's expected. Okay, so that looks good. And so what we should do now is to move our code so we can work on the post method. And the post method inserts a record in the using the to-do item into our in-memory database. Then when we call the HTTP GET, we should have some records showing up. To be able to post, we need to have a content object. In our case, since we're using the JSON, but we're using it as a string, so we'll use the string content. To be able to post, we need to have a content object. In our case, since we're using JSON, we will use the string content because we're going to pass our JSON as a string. Then you can also pass the encoding of the string. In our case, we'll use the UTF-8. And then we'll pass the media type. And so this is so that the HTTP server understands that the body that we're sending it, that string body, is a JSON object. So next, all we have to do is call the post async method using our content. So let's put our code in a try catch and get the HTTP response. Since this code is the same as our HTTP GET, let's just copy that code over. Now we can create our JSON string. The JSON string has to be a to-do item. So we can just copy the class and then convert it into a JSON string. Let's use double quotes instead of single quotes. and then we can escape them using backslashes, so it'll be a proper JSON string. Also, let's remove the quotes from the Boolean value. Since it's not going to be a string, it will be a Boolean value in JSON. And now we can execute our code, and we can see that our JSON body was converted correctly to the to-do item, and the data is saved in the in-memory database. So now if we call our API to get the items, we can see that one record came back. And now if we go and update our code so that we can add a new record, we can see that we have added a new record as well. So let's go ahead and move our code to a different method. So next, what we can do is work on how to do using a put. And if we look at the put is basically updating an existing item, given an ID and the to-do item. So the put method is pretty similar to the post, except we're using a put async. So let's go ahead and just copy that code over and do simple modification to it. And what we can do is change the to-do item, because we need to pass a URL string, an additional value. So in this case, it will be a 2. This is going to be the record number. And then let's actually update the JSON string. Maybe we'll just set is complete to true. So this way we're passing in a JSON string with a query string of 2. And we're going to go ahead and update the post async as well to say put async. And then that's pretty much all we have to do. And let's go ahead and execute our code. So now let's go ahead and go back to our page and refresh this. And as you can see, the record has now been updated to is complete equals true. Let's go ahead and move the put into its own method. And next, what we'll do is work on using the delete. So the delete to do item uses the HTTP delete, and as you can see, it first has a ID. We find the item, and then we remove the item and save the changes. So the delete is very similar to the get, so we'll just go ahead and copy that, and then what we'll do is change the get to a delete. Let's bring it over to our main method and change the URL. So we need to tell it which record to delete. So we'll delete the second record, and then everything else looks good. Let's also go ahead and update the get to say delete. So now if we execute our program, we can see that it will delete the record. So let's go ahead and also move our delete on its own method. And then we can talk about what if you had a HTTP request that did not fall into what we went over. It's not a get, it's not a put, it's not a delete. Let's say it's an option. And how would you actually call this? So the best way to show that is to actually make a option. So we'll just copy and paste the delete, and we'll just change the HTTP options. And then all we're going to do is find a record based on the ID that's going to get passed and return that. Let's just go ahead and also rename the method. So now we have a option method, and now let's go ahead and write the code and how you would call this. Since we have everything in memory, if we stop our service, everything will get wiped, and you'll notice that if we run it again, there's nothing in there. So the first thing we need to do is add some records, so that way we can use the options to retrieve the data. So the options and how you call that is a little bit different. We would have to actually not use any of the get, put, delete and stuff that you've seen. So to do that, we'll go ahead and call the HTTP message. So we'll create a message and then we will send it, and then we should get a response back. So now that we have the HTTP message, all we have to do is in the HTTP method, we'll have options and then the URL, and then the rest of the code should be similar. So we can just copy and paste that. So now the only thing we need here is to have the HTTP response. So we just need to call the send method. So we'll just create a HTTP client and use a send method and passing the HTTP request inside of it. So now that everything looks good, let's go ahead and launch our application, put a debug to see what's going on. Okay, so now we call our method and we're passing ID of 1, but we're not finding anything. That's probably because we're passing the wrong value. Let's take a look at what we have in our in-memory database. It's a value of 2. So let's go ahead and modify our query to pass 2, and then now if we execute our code, we can see the records coming back properly. So that's how you use the HTTP methods that are not methods in the HTTP client. We can use the generic send async. So as a bonus, let's go ahead and see how we can actually send emails. To send an email, you need a SMTP client, and you need to pass it the server in which you're sending emails to. We're going to use Gmail, and then you need to tell it where the mail is going to. So we're using the maximum code, and we're having the display name of what it is rather than showing the email. And then we have the email address, and then we have a message created that has from who and where it goes to. And then we have this little string, and this is to showcase that you can add symbols, and these are the arrow characters, and we'll see how this is going to work. Next, we need to have our credential. In order to use Gmail, you need to have your username and password, and we'll show you how to set that up in Gmail. Next, you need to have the port. We're going to be using not the default SMTP port, it's the 587, and then you need to have enable SSL. Then all we have to do is set up the message body, and then we are now adding the arrows, the characters, and then we're setting the UTF encoding. So because we're passing it these symbols, this is why we have to pass the encoding for the body. And then we have a subject line, and we're also setting that up in the subject line as well. So this is a test message. And we're also setting the encoding for that as well. Then the last thing you do is you're going to go ahead and send the message, and when the message is sent, we give a notification and we dispose the message and we get out of the program. So let's actually execute this code. So our message was sent and everything ended. The next thing we have to do is go to Gmail. As you can see now, we have the message and we have our Unicode characters here, the arrows going up and down, and same thing with the body. So it looks like this message was not delivered, which says address not found. So let's take it to a program and see what we did wrong. So it looks like we have a spelling error. Let's just fix that. Now let's go ahead and resend. And now it looks like it was successful. So now let's take a look at how you set the options to allow this. If you set up your Gmail to be two-factor authentication, then you go to the security settings, and then you want to go to app passwords. So in the app password, so here you can come in and say you want to create other, and set it as, we set ours as API, and then click generate, and that would generate you a password. And then you can take that password and add it into your credentials, and that should get you going. So that's it for the email section port. This concludes our networking with CSWAP section. This will also conclude our beginner to intermediate playlist. After this, we will work on more complex topics to get you past the intermediate to more of an advanced session. So stay tuned, and thank you so much for your support.